Hi everybody, this is Matt Ingram with a quick tutorial on reading, revising, and writing shapefiles. Basically what we want to learn here are the basic skills of loading or importing a shapefile with the spatial geometric information, then loading your own aspatial or non-spatial data that you may have collected elsewhere. Could be in a text format or CSV format or some other tabular format, maybe an Excel file. uh, Merge those two files together, right? An existing shapefile plus your own data, and then write a new revised shapefile that you can then start to use for visualization, mapping, constructing spatial weights, uh, and other forms of spatial analysis, and then ultimately mapping your results. So let's move forward here. Some preliminaries first. Recall the basic structure of a shapefile. A shapefile is more than one file. You need at least three files: the SHP um, extension, the DBF extension, and the SHX extension. We've talked about these in class. I'd refer you back to the Esri technical paper. The SHP file contains the geometric attributes, right? Are these points, lines, polygons? The DBF file contains the attributes of each of your geometries, right? And then I've done some more reading, and the SHX file is a much more accessible or quickly accessible index of the spatial units so that you can search, move, um, um, the geometries, search through the geometries, identify different geometries much faster than it would be if you had to search through the SHP file. So if this were important for some aspect of your research to manipulate the geometries or do some diagnostics of the geometries, conceivably you could do this through the SHX file. Then lastly, we also talked about the importance of the PRJ, the projection format file. This is the file that contains the coordinate reference system. If this PRJ file is missing, then you're not going to be able to layer different maps on top of each other or layer different geometries on top of each other. Maybe you've got polygons, points, and lines, and you want to layer those on top of each other, and then maybe you want to also layer a higher jurisdictional or administrative level of boundaries on top of that, states over municipalities, for instance. You won't be able to do this layering with maps unless you have this projection, this PRJ file. So that's the basic structure of the shapefile we want to recall. And then recall the data from Baller et al., the homicide data over 4 decennial years. The main shapefile is this NAT, the National Homicide Shapefile. This file contains only the three main files that are listed above here: the SHP component, the DBF component, and the SHX component. So with those things in mind, these are the goals, or this is where we're headed in this quick tutorial. We basically want to learn how to load or import a shapefile. We've all done this already a few times, so this step is not new. We then want to be able to read, load, or import your own non-spatial data, whatever data you've collected. The only important part to remember is that the unique identifiers for your geometries in the shapefile must match the unique identifiers for the units in your non-spatial data. We want to then use those unique identifiers to merge the non-spatial data with the shapefile, and then we want to write a new revised shapefile with all of the data above. So this would be ready for all of the analyses that we talked about already. And then lastly, if the projection file is missing, we want to be able to add that. We'll do this here in this tutorial in R. And ideally, we'd like to be able to do these steps in several different software environments, just in case you don't have one accessible to you, or you like working in one more than another. So we'll do this quickly in ArcGIS, maybe ArcMap, Geoda, and then in R. So let's get started with ArcGIS. Here's your blank ArcGIS. I've just opened it from my own programs folder. Again, the quickest way to add data to your to the program is through this plus button. If you already have a map file or a project that you've been working on, you might have saved it elsewhere. It would be saved as this MXD file kind of file. So then you could just open it and it should load all of the data as long as your file paths haven't changed. But again, if you're just starting from scratch, then the easiest way to load data is through that plus sign. We see here the shapefile from Baller et al. We can load that. You can see that it's missing the projection file, so it's giving us a warning that we cannot project this. Still, we can visualize it. This is what the data looks like. You can right-click on the shapefile and then quickly open Attributes table. This table is familiar to us from the earlier replications that we've been doing, and you can see that it ends with FH90. Now what we'd like to do is go into a folder where we have some data, and here I'd like to add this nat LISA. This is some other data. These are LISA values, significance values, and cluster identifiers that I generated in Geoda, just exported into a CSV file as I did quickly in class. So you could load this as a CSV file. This is what it looks like. Has your unique identifier, and then the LISA value, the LISA cluster, and the significance value, the p-value. I've created 3 different versions of this, basically the CSV file, the comma separated value, 1997 sort of legacy version of Excel, 97 to 2003, same exact information, and then a more recent version of Excel, same exact information. So all of these are in my working directory, so I can add any one of these. There's the CSV file, there's the legacy version of Excel, and there's the most recent version of Excel. So you could load any one of these 3, excuse me, here. Let's just start with the CSV file. If we right-click on the CSV file and open it, you should be able to see your unique identifier, the LISA value, the cluster identifier, and the p-value. So we want to merge this data using the unique identifier with the shapefile data using the same unique identifier right here. So how do we do that? We right-click on the shapefile, click Join, and ArcMap automatically uses your base shapefile and then searches for the other data that you've loaded. So it identifies the table that you have loaded here. If you have more than one table, then be sure to tell it which one you want. And then we want to tell it to use the unique identifier FIPS number. It will automatically search through the table to see if it finds that FIPS number. So it's filled in that unique identifier itself. You could run into trouble here if it doesn't find the unique identifier. In some cases, your unique identifier may be saved in a different format than the format that's in the shapefile. For instance, in the shapefile it might be a numeric format, but in your CSV or your Excel file it might be alphanumeric. You just need to go back into your CSV or your Excel file and reformat your data and make sure it's saved in the same format, and then ArcMap should be able to read it. ArcMap may also identify the wrong unique identifier, so just make sure to do a quick inspection here and make sure that it's catching the same identifier. We want to keep all records, and then we can quickly validate the join. ArcMap will search through and make sure that the identifiers match, and here you see that this validation was successful. 3,085 units from the shapefile matched the 3,085 units from the CSV file, and we're ready to join. So then we can just finish by clicking OK. Now here everything is joined together, so now if we right click on the original shapefile, which ended with FH90, we should be able to see that it has added our 3 new variables. And there they are. So it originally ended here, and now it's added all of the data that were in the CSV file. So now we have a new revised shapefile with all of our data. We want to export this. We want to write this as a new revised shapefile. So again, if you right click on the shapefile on national up here and go down to data, you can export this data. Let's make sure our file path is correct. We want to go to our data and replications folder, and let's just call it something different. Nat2 revised. So now we can go back into our folder and see if that's there. Make sure it's saved as a shapefile. There are other options. Make sure it's saved as a shapefile and click save. And click your way out of here. You'll see it takes a little bit of time to process, but now the full shapefile has been saved. It will automatically ask you if you want to add it now over here in the left-hand window as a new layer. You can say no and then simply load it, or you can say yes, and there it is. We could now conceivably, I wanted to remove this and remove the table, and now we only have the revised joined dataset. And if we open the attributes here, we can see that everything is loaded. You have your FIPS number here. It's renamed the variable because there were some duplications, or actually it used the data set of the other of the CSV. So this is the FIPS number, this is the LISA value, this is your cluster identifier, and this is your significance value. Here you might want to go in and change the variable names, or export it and change the variable names elsewhere. So I'll close here. We could remove this, and you could potentially load it if you were looking for it. Load nat2 here as your new shapefile. Keep in mind it still does not have the projection file, so you still would not be able to project it. But there is the new revised shapefile. So let's see what this looks like in Geoda. In Geoda, we could open the same national shapefile. There it is. Here comes our basic themeless map. If we open the table, we can confirm, just as we did before, that the last variable is FH90. And then under table here, you can merge table data. You want to identify your input source, so go back and find either the CSV file or a legacy version of Excel. Geoda won't yet allow you to work with the newest version of Excel, but you could use either the legacy version of Excel or a CSV version of the file. Let's stick with CSV for now. And there's our file, right? NatLISA. So let's open that. We want to merge by the FIPS number. Here's our values in the CSV table, so you can see that we've only got these 4 variables. So let's merge by FIPS number. And we can exclude the FIPS number. Let's bring them all over and then exclude the FIPS number. So we're just going to bring over the LISA value, the cluster, and the significance value. Merge. That was quickly merged. And now if we open the table, we can see there's FH90, but we've added these 3, oops, sorry. You can move these variables around if you want. but we've added these three new variables. So now we could go back under the File menu and export, and we could export as a shapefile. And now let's do it as nat3. Click Save. I'm not going to do a project file. Export this. You can see that it was successful. And we could go back to our replication folder. And here you see, whoops, our original nat2 revision. I think this was a duplicate that I made, or it's being used right now is why it's, if I close this out here, it'll disappear. Should disappear. Maybe not. But there's our nat2, and then here is our nat3 that we just created in Geoda. Notice that, again, that both the new revised shapefile that we created in ArcMap and the new shapefile that we created in Geoda, neither of them has the projection file, the PRJ extension. So we have not yet created a new revised shapefile that contains a projection file that would allow us then to overlay maps and do that kind of work at a later time. So let's see what this looks like in R and see what we can do there to fix this PRJ problem. Here's our basic R window. We can load our script that we'd like to work with. I've got an updated script here. And let me just open all of our packages. I'm just highlighting here and hitting Control R just as we've done before. If you're working in RStudio, your display might look a little bit different, but the commands are all the same. And I'm going to make sure to set my working directory where I want it. And here I've also listed the files that are in there just to confirm that I'm in the right place. Let's load the national shapefile. And we could plot it. I'm just going to hit plot just so that we can make sure that we have the right thing in memory. There it is, just a quick confirmation. Let's go back to our script. So now we could add a projection, this PRJ layer to it, the coordinate reference system, with this command projection for string here. We'd basically use that command and then open parentheses the shapefile name for the shapefile we've just created, and then there are variations on which coordinate reference system you could use. This is one, this is another, this is another, and then we could bring it back to the WGS84. There's several different coordinate reference systems. You could look these up online, or if you look for help with this command, the R help menu should give you various options here as well. So basically we've excuse me, we've only loaded our shapefile into memory. So let's take a quick look at what that looks like, just to summarize it. We can see over here in the console that the last variable is FH90, just as we saw in ArcMap and in Geoda. Now let's load. There are various ways to load your own data in here. If it's in text format, you could use read table. If it's in CSV format, you could use either CSV or CSV2. If it's in tab delimited format, you could use read delim. And then there are a couple of newer packages for reading Excel files directly, but I won't get into that right now. But basically, let's get our working directory again. Well, we know where we are. Let's just list the files. We want to load NatLiza CSV here. So this is the command for loading natliza, read.csv natliza. And given the object-oriented nature of R, we want to create a new object that consists of, using that back arrow, this CSV file. So we want to read the CSV file and make a new object, natliza, out of that CSV file. So let's highlight this, Control R to execute. You can see it executed over here on the left in the console. We could summarize natliza. There's our unique identifier, our 3 variables. Another way is just to look at the names, just the variable names, if you just wanted a quick look at the variable names. So let's take one of these. Let's take the Liza cluster identifier, just this one variable here. Let's take Liza cluster from the natliza object we just created and add that to the nat shapefile. So we're going to take the nat shapefile, and then $ says create this new column that consists of the Liza cluster variable in the natliza object. So let's highlight this whole thing, Control R, and now if we do the names of nat again, we can see down here that Liza cluster was added as a new variable. We could summarize nat again, and there it is again, right? Liza cluster ranges from 0 to 4, right? 0, 1, 2, 3, 4. And there we see that it's been added to our shapefile. So you could do this several times, adding different variables that you've created or different variables that you've manipulated or transformed. You could add those to your shapefile and then write a new shapefile. This is the command write shapefile, consisting of the revised shapefile, all the variables that you've added to the old shapefile, and the new shapefile will be called nat2 rev. We've already done nat2 and nat3, so let's do nat4 just to keep them separate. Let's see what that looks like. So I'm going to highlight that and hit Control R, and then we should see that appear. There it is. Again, you see that the projection file is missing. So let's fix that. We see that there's only 3 main files, right? The SHP file, the DBF file, and the SHX file. So if we create, we can see here that if we try to write, you use the write OGR to make sure that you include the projection file. If you use this and there is no projection file, let's see, where are we? It won't create it, right? You see that. Well, just to be super clear, just replace them. But let's just delete these so that we're not getting confused and run this. You can see that there is no projection layer since the PRJ file is missing. The coordinate reference system is missing, so you get an error if you use write OGR. However, if you go back and use the projection for string command that I introduced just a few minutes ago and create that coordinate reference system, now you can use write OGR. It's giving me an error here. Hang on just 1 second. Hi folks, okay, we're back. It was trying to replace the shapefile over an existing file, so it didn't want to write a layer where it didn't exist. But again, I'm just going to repeat the command here of creating the coordinate reference system, and then I've just created nat5, so it's not trying to write over an existing shapefile. And if we do write OGR, you can see that it executes over here. This write OGR, as opposed to write spatial, will write the SHP, the DBF, and the SHX, but not the PRJ. Write OGR, if you've created a coordinate reference system with this command, write OGR we'll also write the PRJ file. And if we go back to our working directory, you can see here nat5 includes shp, dbf, shx, and the PRJ file. We can do a quick confirmation that this works by going into arc map. Remember that with our original shapefile, it gave us an error message that it didn't have a projection layer. And here we see with nat5, it now has the projection layer. We get no error. So that's a quick tutorial on reading, revising, and writing shapefiles. Thank you.